Collaborative learning fosters critical thinking and engagement. In computer science, pair programming is the most widely adopted technique to conduct collaborative programming exercises. One student is assigned the driver who writes code, and the other the navigator who provides feedback and guidance to the driver. Many studies show effectiveness of pair programming to learning outcomes and to long-term academic success. But pair programming is an unbalanced collaboration technique. The navigator is strongly dependent on the driver to write the code, but the driver has only a weak dependency on the navigator. They can work on the solution without involving them. This can lead to ineffective collaboration. For example, Rodriguez et al. Found that pair programming episodes where the driver scarcely communicated yielded a lower learning outcome. In this work, we explore the design of an alternative collaborative programming tool that addresses the imbalance in pair programming by introducing a dependency between both partners. We use Parsons problems as a basic interaction technique. That is, pairs must rearrange fragments of code into the correct order. We then split a Parsons problem into two parts, a helper function and the parent function, and assign one to each learner. Thus, each person can only edit their space. This coordination condition, denoted personal spaces, may encourage students to engage in more dialogue, for example, to negotiate for blocks and resolve conflicts, and lead to a sense of responsibility and ownership over the final solution. To evaluate our design, we compare it against two other coordination conditions. Shared control, where both students can edit both the spaces, and turn-taking, where only one of the students can modify the solution at a time, but partners can swap control to alternate roles, akin to pair programming. We compared collaboration afforded by these conditions in a study with 9 pairs of undergraduate students, where each pair completed bubble sort, insertion sort, and selection sort using one of the coordination conditions. We find pros and cons to each condition. For example, personal spaces promote engagement for both partners, but sometimes participants divided and separately tackled each subpart. Turn-taking helped participants collaborate towards a single vision of the solution, but often had one person controlling the entire session. Please see the paper for more details. Our main conclusion is that personal spaces provide a promising start to allow both participants to gain insight and interact with the chosen problem. However, more work is needed in 1. Understanding how different strategies structure participant discourse, and 2. Designing problem sets that can be divided evenly and whose subparts still depend on one another in a non-trivial way.